Hi everyone, welcome to our session 8 where we're going to talk about a very interesting topic, lean and just-in-time operations. We will cover what is meant by the term lean operation system and benefit of this lean system, and also we will looking into lean tools and important consideration converting a transitional mode of operation to a lean system, and also we will point out the importance of just-in-time in lean manufacturing. Lean manufacturing is widely considered by Taichi Ono, who was an industrial engineer and executive at Toyota Motor Corporation in Japan. So Toyota was founded in 1937 by Kiichiro Toyota, the son of Japanese inventor. The company initially focused on producing automobiles, and by 1940s it had become one of the Japanese leading manufacturers. So after World War II, of course, things was different. But in 1952, they began to address some of those challenges by developing the Toyota production system. So you can see from 2,700 cars daily to 28,000 cars in 2021, and largest manufacturing award in 2021. So those TPS emphasize the importance of reducing waste, improving quality, empowering workers to identify and solve problems in productions. We mentioned TPS or Toyota Production System is a manufacturing system developed by Toyota in 1950. It is based on the principle of lean manufacturing and designed to eliminate waste, improve quality, and increase efficiency in production system. The TPS compromise of two main pillars, which is just in time, you can see from the picture here, and JIT. The PDS also emphasize on continuous improvement or Kaizen in all aspects of the production system. This means that workers are empowered to basically identify problems such as improvement to the system, leading to a culture of ongoing improvement. So you can see we have term Jiduko is a quality at the source, Muda, waste and inefficiency can be minimized, Kanban in a manual, it's a manual system used to controlling the movement of the parts, and Haijunka is variation in production volume led to waste, and Kaizen, which may be mentioned, continuous improvement. Overall, the TPS has become widely recognized and influential approach to manufacturing and has been adopted by many companies in variety of industries. Its focus on efficiency, quality, continuous improvement has helped Toyota become one of the most leading automakers. Lean operation is a management philosophy that aims to maximize efficiency and eliminate waste in business processes. It is based on principle of TPS or Toyota Production System and focus on creating value for customers while minimizing resources and reducing waste. The main principle of lean operation includes defining value for the customer perspective and ensuring that every step is in the process of add value to the product or service. Understanding the flow of the work and identify areas of waste that can be eliminated, ensuring that work flows smoothly and efficiently through the system without delays or any bottlenecks. And also establishing a system where work is pulled through the process by customer demand rather than being pushed through by production schedule. Pursuing continuous improvement in all aspects of the operation with the goal of eliminating waste and creating greater value for customers. In general, lean operation can be applied in wide range of industry from manufacturing to healthcare to service industry. It involves a collaborative effort across all levels of organization with the focus on empowering employees to identify areas for improvement and make changes to the system. By implementing lean operation, organizations can benefit from greater productivity, lower costs, shorter cycle time, higher quality, and ultimately increase customer satisfaction. In lean operation, waste refers to any activity or process that does not add value to the product or service being produced. Waste is also referred to as MUDA in TPS. The goal, as we mentioned, is to identify and eliminate any waste in process, increase efficiency, reduce costs, and improve quality. There are 7 ways in lean philosophy or lean operations. The first one can be excess inventory. When we holding excess inventory, which ties of capital increases the risk of damage or loss. Producing more than is needed, which leads to excess inventory, that's called overproduction, increased costs and reduced flexibility. Waiting time, any delays or waiting time in production process can which cause bottlenecks and reduce efficiency. Transportation moving product or material unnecessarily, which can increase cost and cause damage or loss. Processing performing unnecessary or inefficient operation, which can add time and cost to production processes. Motion, unnecessary movement of people or equipment, which can cause fatigue, injuries, and waited time. And also product defect, producing products or services that do not meet customer requirement, which can lead to rework, scrap, and customer dissatisfaction. So by identifying and eliminating waste, organization can improve their processes, reduce costs, and increase customer satisfaction. Where lean operation involve a continuous effort to identify those ways with the goal of achieving maximum efficiency and value for the customer. There are differences between lean and traditional philosophy. You can see the factors like inventory, delivery, lot size, setup of runs of vendors of workers. In traditional and lean philosophy, there are differences. For example, in traditional philosophy, we're looking into for inventory much to offset forecast errors, late deliveries, but in lean we try to minimize those, the inventories to be able to be working as minimum necessary to operate. So you can see the differences between traditional and lean philosophy here. Transition into lean operational system require a systematic and collaborative approach that involve all levels of the organization. Here are some of those examples. So for example, make sure top management is committed and that they know what will be required. Decide which parts will needed to be to the most effort to convert. Obtain support and cooperations of worker began by trying to reduce setup time while maintaining the current system and gradually convert operation, begin at the end and work backward, convert supplier to just in time and prepare for any future obstacles. Transitioning to lean operation can be challenging, and there are several obstacles that our organization may face during this process. For example, management may not be fully committed or willing to devote the necessary resources to conversion. Workers or management may not be cooperative. It can be difficult to change the organization culture to one consists with the lean philosophy. Supplier them might resist. We might have lack of resources or even lack of leadership supports that we mentioned. So there are so many different obstacles. It can be unrealistic expectation. Maybe organization may have some sort of expectations or unrealistic expectation about the benefit of lean operation and the speed at which improvement can be made. To overcome this obstacle, organization must have a clear understanding of those challenges that they will face and develop a strategy to address them. This may include providing training and education to employees, building a culture of continuous improvement, securing leadership support, and investing in resources and infrastructures. Organization must be patient and committed to the process, understanding that the benefit of lean operation may take time to materialize. Now let's move to goals and building blocks of lean operation. The goals of lean operation are to create value for the customer by eliminating waste, increasing efficiency, and improving quality. So the ultimate goal of lean operation is to achieve a system that matches supply to customer demand. System is synchronized to meet the customer demand in a smooth and uninterrupted flow. So you can see from this graph that we have, so ultimate goal on top, then we have supporting goals, eliminating disruptions on the right side, eliminating waste, and then we have the building blocks, so product design, process design, personnel or organization elements, and manufacturing planning and control here. By focusing on these building blocks, organization can create a lean operation system that eliminate waste and improve efficiency and increase customer value. The ultimate goal, as we mentioned, is to create a culture of continuous improvement where every employee is committed to identify and eliminating waste and improving processes. So in lean operation, there are four building blocks: product design, process design, personnel organization elements, and manufacturing planning and control. Let's go in detail and see what are each of them. Product design in lean operation involve designing products with the focus on meeting customer needs and eliminating waste in the design process. This technically means considering the entire life cycle of the product from raw materials to disposal and designing product that can be produced efficiently with minimal waste. So there are four elements in product design. So it's very important to lean system. A standard parts, worker have few parts to deal with. Modular design is an extension of a standard part, reduce the number of parts to deal with. Highly capable system with the quality built in. Quality must be embedded in quality and processes, and concurring engineering. Engineering change can be very disruptive to a smooth operation and can subsequently reduce these disruptions. Now we come to process design. In lean operation involve designing processes that are efficient, effective, and eliminate waste. This means designing processes that are flexible, can handle changes in demand, and are easy to change and improve over the time. So there are eight aspects of process design that are important for lean system: small lot size, setup time reduction, manufacturing cell, quality improvement, product or work flexibility, a balance system, data inventory storage, and fail-safe method. Let's have a look at some of those eight aspects that we mentioned. One of them was a small lot size. In the lean philosophy, the ideal lot size is one unit, and quantity that may not always be realistic or owing to practice considering require minimum lot size. So we try to reduce the inventory level, where reduce the space and increase the flexibility. Another aspect is setup and time reduction. So small lot sizes and changing product mix require frequent setup. Unless these are quick and relatively inexpensive, they can be prohibitive. Setup time reduction required deliberate improvement effort. One of those methods is, we call them single minute exchange of die, or SMED, is a lean manufacturing technique developed by Shiego Shingo that focus on reducing the time it takes to change over a production line from one product to another. The goal of SMED is to reduce the setup time as close to a single minute as possible. So it involved breaking down the setup process into two categories: internal and external setup. Internal setup is a process that requires the production line to be stopped. An external setup is a process that can be done while the production line is still running. The goal is to convert as many internal setup tasks into external setup tasks as possible to reduce the time required to change over the production line. So by reducing the time it takes to change over the production line, organization can increase flexibility, reduce inventories, and also improve efficiency, which lead to cost saving and increase customer satisfaction. So SMED is a very powerful tool in lean technique that has been adopted by many organizations around the world, and it continues to be essential tool for lean manufacturing practitioners. Manufacturing cells and other aspects. One characteristic of lean production system is multiple manufacturing cells. The cells contain the machines and tools needed to process families of parts having similar processing requirements. There are many benefits, but let's have a look at just three important ones: reduce the changeover time, high equipment utilization, and ease of cross-training workers. Quality improvement is another aspect. So quality defect during the process can be disruptive, and also it can be ordinary flow of the work. So one term here is automation or jidoka. Jidoka is a Japanese term that often translated as automation with a human touch. In the context of lean manufacturing, Jidoka is a quality control approach that involves detecting and addressing problem at the source to prevent defect from being passed on to the next process. So automatic detection of defect during production can be two mechanisms, one for detecting defect when it's happening, another is to stop production to correct the cause of the defect before we continue. As we mentioned, production or work flexibility is another aspect of process design. So there are guidelines for increasing flexibility. So cross-trained workers can help when bottlenecks happens or other workers are absent. The use of many units of capacity, many small cells makes it easier to shift capacity temporarily and to add or subtract capacity. Another aspect of process design is a balance system. So we're looking into distributing the workload evenly among workstations. There's a term here called takt time. So takt time term is a term that used in lean manufacturing refer to the rate at which a finished product needs to be produced in order to meet the customer demand. It is calculated as the available production time divided by the customer demand for the product during the same time period. So takt time often set for a work shift. The procedure is like this. Determine the net time available per shift. If there is more than one shift per day, multiply the net time by the number of shifts and compute the takt time by dividing the net available time by demand. Let's have a look at the example here. Total time per shift is 480 minutes per day, and there are two shifts per day. There are two 20 minutes rest break and 30 minutes lunch break per shift. Daily demand is 80 units. So we have the total time of 480. We need to minus those break times. So we have rest breaks and lunch break. So we have 410 minutes per shift. So it mentioned two shifts per day, so it will be 820 minutes per day. So if we follow the takt time formula, which is net time available per day divided by daily demand, our daily demand was 80, we reached to 10.25 minutes per cycle. Another aspect in process design is inventory storage. Lean systems are designed to minimize inventory storage. Technically, inventories are buffers that tend to cover up those problems or reoccurring problems that never resolve, partly because they're not maybe obvious, or partly because the presence of inventory makes them seem less serious. This is a fantastic example that we're talking about those inventory storage. So large rocks are the problems, are hidden by a high water level, which is our inventories in picture A. We need to lower water level in picture B, so it reveals those rocks, the big rocks, problems such as bottlenecks, waste, poor timing. Once the large rocks are removed or we solve those issues, the water level inventory can be lowered so that our inventory can go down. This process would be done repeatedly in a spirit of continuous improvement, achieving additional improvement with each irritation. Another process design, which we already covered this before, is fail-safe method, or we can call it mistake proofing or Pokayoke technique, are used in lean manufacturing to prevent defects from occurring or to detect them early in the process before they cause problem downstream. The goal of fail-safe method is to eliminate need for inspections and rework, reduce defect, and improve quality. So you can see there are examples here: electric breakers, seatbelt fasten warning, or ATM signal if the car led in a machine, designing parts that can only assemble in a correct position. By implementing this method, organization can reduce those defects, improve the quality, and increase efficiency. Another building block is the personnel and organization. So It is the element of the building blocks of lean operation. They refer to the people and organizational structure of a company and how they are aligned to support the implementation of lean principle. There are five important elements here for lean system. Workers seen as an asset. Um, they provide cross training for workers, continuous improvement, cost accounting, and also leadership and project management. Under this building block, which is personal and organization, continuous improvement sitting here. Working in lean system have greater responsibility for quality and they are expected to be involved in problem solving and continuous improvement. One of the system here used called Andan. Andan again is a Japanese term and refer to visual control device uses in lean manufacturing to alert operations supervisor management to problems in the production process. The Andan system is designed to enable quick identification and resolution of problem, helping to minimize the downtime, reduce waste, and improve quality. The Andan system typically consists of signal device such as light or sound that is activated when the operator detects a problem in the production process. Signal is then displayed on board or screen indicating the nature and location of the problem. The Andan system may also be linked to control center where manager can monitor the status of the production line and respond quickly to any issues that arise. So in unknown system, we might have, for example, light. So those light can be green, yellow, and red. Lean worker receive training to be able to look into a statistical process control, quality improvement, and problem solving. Manufacturing planning and control is another building block. Is a key element of lean operation. It involves the processes and system used to manage and optimize the production of goods from the planning and scheduling of productions to the control of materials, inventories, and resources. MPS is typically divided into two main components planning and control. Planning involve forecasting demand, determining the production schedule, and setting targets for production levels and inventory levels. The other one is controls, involve monitoring the production process in real time, identifying any deviation from the plan, and taking correction action as needed. So there are seven elements of MPC are particularly important to lean system. Level loading, pull system, visual system, limited working process, close vendor relationship, reduce transactional processing, and preventing maintenance and housekeeping. Let's go through each one of them and see what are those. Level loading. Lean system places strong emphasis on achieving a stable level daily mix schedule. So here we have master production scheduling developed to provide level capacity, and also we have mix model scheduling. That there are three issues need to be resolved. What is appropriate production sequence to use? How many times should the sequence to be repeated daily? And how many units of each model should be produced in each cycle? Let's have a look at this example for level loading. So we're trying to determine the production plan for these three models using the sequence ABC. So for example, model A, we have the daily quantity of 7, model B, we have 16, and model C, we have 5. So you can see on the right side, so we try to find out the cycle and we identified our 5 cycles. So if we divide everything to 5, we can see there are 5 cycles we can identify here. Then in terms of the patterns, we try to say, okay, we try to balance it. If you can see in front of the patterns, we put 1A in cycle 5, maybe 2A in cycle 2. We need for A, we need to reach the 7. So we try to balance it. We don't put all 7 in cycle 1. Also, you can see, for example, for B is same. We try to balance it up. Maybe one of them would be higher. So what we do is we're looking into, all right, maybe cycle 3, we have only one A. We can increase the B to 4. And also C because it's just 5, so it's just what we do is just put C in every cycle. Pull and push system are two approaches to production planning and control that are used in lean operation. In push system, production is planned and controlled based on anticipated demand. Products are produced in advance based on forecast demand and stored in inventory until they are needed. This approach is often used in mass production environment where high volume production run are required to achieve economy of scale. In other hand, we have pull system. Production is planned and controlled based on actual demand. Products are produced only when they are needed based on actual customer order. This approach is often used in lean manufacturing environment where minimizing inventory waste are a key objective. A pull system is based on a principle of just-in-time manufacturing, which involve producing and delivering products to the customers, consuming exactly when they are needed in exact quantity required and with exact quality required. Overall, pull system are considered more effective than push system in lean operation as they enable organization to achieve higher levels of efficiency, productivity, and quality while minimizing waste and inventory. One term in manufacturing planning and control is Kanban, which is a visual system. Kanban is a lean manufacturing technique that is used to control and manage the flow of materials and information production system. The term Kanban comes from Japanese word kan means visual and ban means card, sign, or signal. A Kanban system uses visual signal such as card or lights to indicate when materials or components should be replenished, when production should start or stop, and when work should be moved to the next stage of production process. These signals are used to trigger the production and movement of materials only when they are needed based on actual demand. There are some benefit out of Kanban system. So it helps to optimize the flow of materials and information in the production system, reducing the amount of time and effort required to move products through the production processes. By producing only what is needed when is needed, Kanban helps the system to reduce inventory levels, free up space, and reducing risk of waste and obsolescence. Also, Kanban helps to ensure that materials and components are the right quality and quantity, reducing the risk of defects and rework. And also, Kanban system enable organization to respond quickly to changes in demand as the system is based on actual demand rather than forecast demand. Kanban is often implemented using physical board or electronic system that display the status of each stage of production, including amount of work in progress, the status of each task, and any bottlenecks or delay. This visual system approach helps to improve communication and collaboration among team members, enabling them to work together more effectively to achieve their goal. Limited working process or WIP is a key principle in lean manufacturing and under the building block of manufacturing planning and control that emphasizes the importance of minimizing the amount of inventory that is in process at any given time. In a production system, WIP refer to the materials and components that are in the process of being transformed into a finished good. So there are some benefit of lowering the working process, lower carrying costs, increase flexibility, aids scheduling, save costs of scrap and rework if there are design changes, and lower cycle time variability. Close vendor relationships are key building blocks of manufacturing planning and control in the lean operation as they enable organization to work closely with the supplier to improve quality, reduce lead time, and minimize cost. There are some benefit out of close vendor relationship. For example, by working closely with supplier organization can establish clear quality standard and ensure that the supplier meet this standard consistently. This helps to reduce defect, rework, and waste in production system. Reducing lead time is another benefit. So close vendor relationship enable organization to collaborate with supplier to improve the efficiency of the supply chain, reducing lead time and enabling faster process time to changes in demand. One of the factors would be lowering the cost. By working closely with supply organization can identify opportunity to reduce costs such as by implementing joint cost reduction initiative or negotiating better pricing based on long-term commitment. And of course, one of the main important things here enhancing innovation. Close vendor relationship enable organization to collaborate with supplier to develop new products and processes leading to greater innovation and differentiate in the marketplace. To establish close vendor relationship, organization must build trust and collaboration with the suppliers. This can only sharing information and as well as sharing some informations such as production schedules and demand forecasting and working together to identify opportunities for improvement. It may also involve implementing joint initiatives such as share inventory management or joint quality improvement program. Ultimately, close vendor relationship require long-term commitment to collaborations and continuous improvement. Another key element here is reduced transaction processing. So lean systems seek to reduce the costs associated with the hidden factor. We're looking at, for example, logistical transaction, ordering, execution, balancing transaction, forecasting, production planning, production control, quality transactions, determining and communicating specifications and monitoring, change transaction, engineering change, bills of material, scheduling, processing instructions, and so on. Preventive manufacturing and housekeeping are two building blocks of manufacturing planning and control in lean operation. So preventing maintaining involve performing regular maintenance on equipment and machineries to prevent breakdown or downtime. By implementing a preventive maintenance program, organization can improve equipment reliability, extend the lifespan of the asset, and reduce the risk of unplanned downtime. Preventive maintenance can also help to reduce the risk of defects and errors in production processes, leading to improved product quality. The other one is housekeeping, on the other hand, refer to the practice of keeping the workplace clean, organized, and free of any clutter. This includes maintaining a tidy workplace, properly storing tools and equipment, and regularly clean and sanitizing surfaces. Housekeeping is important factor here because a clean and organized workplace can help to improve efficiency and reduce the risk of accidents or injuries. It can also help to improve morale and create a more positive work environment. When we're talking about housekeeping, there are five S's here. Sorting, decide which items are needed to accomplish the work and keep only those items. Straightening, organize the workplace so that needed items can be addressed or accessed quickly and easily. Sweeping, keep the workplace clean and ready for work. Perform equipment maintenance regularly. A standardization uses standardized or standard instructions and procedures for all work, and of course, self-discipline. Make sure that employees understand the need for uncluttered workplace. And last topic of today, and one of the most important topic in lean operation is just in time. Just in time or JIT is a lean manufacturing strategy that involves producing and delivering products just in time to meet customer demand without building up excessive inventory. JIT is based on principle of producing only what is needed when is needed and in the quantity that is required. So basically there are some benefit that just in time have. Just in time minimize the amount of inventory that must be stored and managed, which reduce inventory carrying costs as well as the risk of inventory obsolescence and waste. JIT enables organization to produce goods more efficiently by reducing waste, minimizing setup time, and improving flow through the production process. JIT requires a high level of quality control as there is a little room for error or rework. This focus on quality can help to improve product quality and reduce defect. And of course, the last one would be faster response time. This method or philosophy enables organization to respond more quickly to changes in customer demand as they can adjust production level in real time to match changing requirement. So implementing JIT requires focus on continuous improvement and commitment to creating culture of efficiency and waste reduction. Organization must also work closely with supplier to ensure that they can deliver materials and components on a just-in-time basis. JIT requires a high level of coordination and communication throughout the supply chain, as any disruptions or delay can have a significant impact on production schedule and customer satisfaction. Vendor managed inventory is another lean inventory management system where a supplier manages the inventory level of a customer. With vendor managed inventory, the supplier is responsible for monitoring the inventory levels, forecasting demand, and replenishing the inventory at the customer location. This is typically done using electronic data interchange (EDI) or other automated system that allows for real-time tracking of inventory levels at customer demand. So there are some benefit out of that VMI or vendor managed inventory, reducing inventory carrying costs, improve inventory accuracy, increase efficiency, and improve customer service. Implementing BMI required close collaboration and communication between supplier and the customer, as well as high degree of trust and transparency. It's also required the use of sophisticated technology system and data analytics to track inventory levels and forecast demand accurately. In overall, VMO is very powerful lean or inventory management strategy can help to reduce costs, improve efficiency, and increase customer satisfaction. And that's it for today's session. We have covered many interesting topics as well as many interesting terms that help us to be able to achieve lean operation and just in time. I hope you enjoy this session and I wish you all the best and good luck.